All right, so this is the last lesson on factoring. It encompasses everything that we've learned about factoring. So we may or may not use every type of factoring, but what's important to know is that you can attempt them all. So the first thing you're always going to do is look for a GCF. That is extremely imperative. Even if the polynomial does not have a GCF, you always need to attempt it. Then, of course, if it's a binomial, you're going to see if it meets the requirements of dots. And if it's a trinomial, you're going to try to break it down into two binomials. Now, when it says completely, that means you're going to break the polynomial down into prime factors. So let me give you an example of what prime factorization looked like to you before you got to algebra. Say, for example, you took a number like 36, and you needed to break 36 down into its prime factors. Well, you could say, oh, I know that 9 times 4 is 36, but neither 9 nor 4 are prime. So then you needed to break 9 down into 3 and 3, and 4 down into 2 and 2. And now all of these numbers are prime. So that finally down there is your last line of all the prime factors. Now we end up rewriting it as 3 squared times 2 squared, but that's no different than just 3 times 3 times 2 times 2. So you're going to do the same type of process, but algebraically now with polynomials. So let's start with the first one. We have 5x squared minus 45. So again, the first type of factoring we always try is GCF. We only have a binomial here, so we only need to see if if those two terms share something in common, and they do. They share a factor of 5 in common. So with GCF, you put the GCF on the outside of the set of parentheses. If your original term, polynomial, had 2 terms, your quotient inside the parentheses will also have 2 terms. 5x squared divided by 5 gives us x squared, and negative 45 divided by 5 is negative 9. Now we need to pay attention to what we have on the inside. In the past, we stopped here. And if we go back, we actually would see that what we had was prime, which is why we stopped. This 5, or this GCF, even if it were a number like 8, because it's already on the outside of the parenthesis, we just drop it down. Then we analyze before assuming if we can move any further with x squared minus 9. So for starters, that's a binomial. If something is a binomial, you should immediately say, can I do dots? You're going to ask yourself that question. You're not necessarily going to do it. So let's see if it meets the requirements of dots. Is it a difference? Yes, it is. Is it a binomial for the t for 2? Yes, it is. Are both of the terms perfect squares? Yes, they are. So because the answer to this is yes, then we break down into 2 separate parentheses. The square root of x squared gives us x and x, and the square root of 9 gives us 3 and 3. Because this needs to be a negative 9, signs are going to be different, which gives us a positive 3 and a negative 3. Now, you really should look and analyze the remaining factors in the sets of parentheses. Only one of them would be eligible to move further because it is a binomial attached by subtraction. So it really would be this one. So if we check to see if it meets the requirements of dots, it is a difference, it is a binomial, but they are not perfect squares. That's how you know you're done. X plus 3 would never even be eligible for a difference of 2 squares because right off the bat it fails the first requirement, which is that it has to be a difference. So these are your prime factors. That means those 3 factors, if we multiply them, will bring us back to the original polynomial. I'm just going to write down here that these are all the factors of the original polynomial. All right, the next one. First thing we always try is greatest common factor. So that being said, we look at the trinomial here. 3x squared minus 3x minus 18. I hope that you all see this first 3 right here and that they're all divisible by 3. Usually that leading coefficient can be the GCF, and if it is, it usually makes life a little bit simpler. So the 3 goes on the outside. We make a wider parenthesis because now we're dividing 3 terms by 3, meaning we're going to have 3 terms left in the set of parentheses. So we're going to divide them all by 3, giving us x squared minus x minus 6. Now, we're going to analyze, which just means look at a little closer, that polynomial in parentheses. We need to ask ourselves, is this going to be dots? Well, is it a difference? Well, actually, they both are subtraction, so sure. Is it 2 perfect squares? Definitely not. What does that mean? It means we're not doing dots, but we do have another tool up our sleeves that we could technically use, and that is the trinomial tool. So a trinomial tool means that I know how to factor trinomials, especially when the leading coefficient is 1. That's usually the easier ones. We're going to look for 2 numbers that multiply to 6. So that means our options are either 1 and 6 or 2 and 3. And because it needs to multiply to be a negative 6, the signs are going to be different, which ultimately means that the pair I pick is not adding, it is subtracting to the 1 in the middle here, which would imply we're using 2 and 3. So the only way to get to x squared is x and x. The pair of numbers we're going to choose, or at least attempt, are 3 and 2. The negative here for the 6, aka our C term, is implying that our signs have to be different. And then the middle term will always tell me the bigger. So if the middle term is negative, the bigger product, which would be 3x, needs to be negative. And because the signs need to be different, the positive will go with the 2. Now, again, what you need to do is analyze to see if we're done. So we look at x minus 3. Well, x minus 3 is a difference of 2 numbers, but it is not a difference of 2 squares. It is a difference. It is a binomial. It is not a difference of 2 squares, meaning I cannot take the square root of x and I cannot take the square root of 3 and get whole rational numbers. So what does that mean? That means the 3 is finished. The x minus 3 is finished. And now if we look at x plus 2, it is a binomial, but it is not a difference. So right off the bat, we know we're done. Notice how I need to keep looking. A lot of students will always ask me, how do you know you're done? I don't know I'm done. I'm looking deeper. I'm analyzing. I'm asking myself all the questions that I would ask myself regardless of if it said factor completely or if it just said factor. So, you know, the more of these you do, the better you'll get. And sometimes you're going to try to keep going and you're going to notice, oh, no, I can't. And that's all right. That just means that you already had the prime factors after factoring once. Okay, let's look at the next one. As always, we always start with looking for a common factor. Remember, common factors can be letters or numbers or a product of the two. If we look at y to the 6th and y to the 4th, it's clear that they both have a y in common. As far as the exponents go, if you remember back from the GCF lesson, we picked the smaller of the two because that's the most we could take away from each one of those terms. We make one set of parentheses. They're not going to be super wide because we're only putting 2 terms in there. When we divide y to the 6th by y to the 4th, we get y squared. Ultimately, we're subtracting exponents when we do division. Then we have minus, and please do not forget that anything divided by itself is 1. Some students will forget about that -1 completely altogether and just leave it as y squared in parentheses. Because the original polynomial was a binomial, you want to make sure that the quotient in parentheses is also a binomial. All right, let's now analyze this. You don't have to write the word analyze, but just understand that that's what I'm doing now. I don't really know if I should keep going. I need to look at it and think about it. That being said, it is a binomial. So I'm going to ask myself, can I attempt dots? Is it a difference? It certainly is. 2, are there two values or two terms there? Yes, there are. Are they both perfect squares? Absolutely. I can take the square root of y squared and I can take the square root of 1, which means I can do dots. The y to the 4th drops. The original y squared minus 1 now turns into 2 sets of parentheses. I take the square root of y squared, which is y. I take the square root of 1, which is 1. And then because it has to be a negative 1, our signs are going to be different. Notice we don't even look at the sign of the bigger. There is no bigger value. They're both the same number. So then they get 1 of each. Again, we may not necessarily be sure that we are finished, so we analyze. Y to the 4th is done. Y plus 1 is a binomial, but it is not a difference of 2 perfect squares. So then it's done. Y minus 1 is a difference of 2 not perfect squares. Oops. So because it's not a difference of 2 squares, we cannot move forward. We just drop it down as y minus 1. And these are your prime factors. All right, 3 more, and then you'll practice on delta math. Okay, first thing we try, GCF. What do these both have in common? An x. We make 1 set of parentheses. 2 terms to start, 2 terms in here. Divide out an x, which means subtract the exponents, giving us x squared minus 9. Theoretically, x to the 0 can go here, but anything to the 0 power is 1, so the negative 9 times 1 would just stay 9. The x drops. We analyze the polynomial in parentheses. It is a difference of 2, certainly is 2 because there are 2 of them, perfect squares. This works. So we do it. We make 2 sets of parentheses. Square root of x squared is x. Square root of 9 is 3. One of them gets a positive, one of them gets a negative. Again, we analyze. The original GCF is always done. The x plus 3, that's done. It is a binomial. It is not a difference. We don't even question it. X minus 3, it is a binomial. It is a difference. But neither x nor 3 are perfect squares. Therefore, notice I didn't even change anything. There was no point in writing it. I'm finished. Next one. First thing we look for is GCF. Does this trinomial share a common factor? The answer is yes. Remember, GCFs do not have to be numbers. They can also be letters, just like it was here. Well, in this case, they all have an x in common as well. Notice my set of parentheses is wider than it was in number 4. Because I have 3 terms here, I will have 3 terms inside the parenthesis. When I remove an x from x to the 5th, I get x to the 4th. When I remove an x from negative 4x squared, negative 4x cubed, I get negative 4x squared. When I divide negative 32x by x, I get negative 32. This one's a little bit different because we do have a trinomial. So when we analyze, again, you don't have to write this, but just understand that that's what you're supposed to be doing. You're analyzing that trinomial to see if you could break it down any further. The GCF always drops. You say to yourself, well, let me see. Can I find 2 numbers that multiply to 32? And because the signs are going to be different, subtract to negative 4. Well, let's see. Our options for 32 are 1 and 32, 2 and 16. After 2 comes 3, 3 doesn't work, 4, 4 and 8. 4 comes 5, 5 doesn't work, 6 doesn't work, 7 doesn't work, 8 works, but 8 is already there. So these are my only 3 pairs of factors that give me 32. Will one of them subtract to 4? Absolutely. Again, I know they subtract because this is a negative c. When this is a negative c, signs are going to be different. When signs are different, it's going to subtract to the b term. So that means I would put an x squared in the front of each set of parentheses because I need to ultimately multiply to x to the fourth. I'll put a 4 and an x in parentheses. Signs have to be different. Bigger one gets the negative. So as far as what's bigger, the bigger one here is actually 8. So 8 gets the negative, which would then mean x squared plus 4 would get the positive. Now, this is actually ironic, and I almost feel like I made a typo. I would have loved to keep going with this one, but I actually cannot. X drops. We're going to analyze x squared plus 4. X squared is a perfect square. 4 is a perfect square, but it's not a difference of two perfect squares. It's a sum of two perfect squares. So this guy is done. Now let's look at x squared minus 8. It looks like it's going to be a difference of 2, unfortunately, not perfect squares. So this is also done. No need for me to rewrite it. I just wanted you to see and hear me analyze as I checked to see if I could keep going. I actually probably would have preferred us to keep going just to see that if I had x and x squared minus 4 and then x squared plus 8, this one would actually be able to keep going. I would actually be able to keep getting factored because it would be a difference of two squares, but it's not, which is why we're done. All right, and then last but not least, that last one there. As far as GCF is concerned, they all are divisible by 2. No, they're not. I thought 20, but 26 is not divisible by 20. Well, they're all even numbers, so let's see. 2 would work. I think 2 might be the highest because 26 divided by 2 is 13, and that would not break down any further. So I'm going to make a wide parenthesis, 3 terms to start, 3 terms inside, gives us 10x squared plus 13x minus 30. This is a different type of factoring. It is a trinomial, so I'm just going to write here, analyze. We need to see if we can keep going, or we need to try to keep going. I'm going to drop the 2. The 2 is done. I'm going to make 2 sets of parentheses. This is our trial and error. Why? Because this 10 is going to throw us a little curveball. I'm going to try 5x and x. May not work, but I'm going to try it. And for 30, we have 1 and 30, 2 and 15, 3 and 10, and 5 and 6. Now I need this outer and this inner to give me 13x when I subtract them because this is a negative. So let's see. If I did 5 and 6, I could not put the 5 with the 5. So the 5 would go here and the 6 would go there. If we check that, we would have 6x and 25x. Well, let's see, what do 25 and 6 subtract to? 25 minus 6 would give me 19. So that is not the right choice. Notice how I said try. It's called trial and error. Now 3 and 10. I would not put the 10 here with the 5 because they would have something in common, which means I'll try the 10 here and the 3 here. That would give me 3x, and that would give me 50x. And oh my goodness, when I subtract those, I do not get 13. So let's try again. Notice I'm not trying the 10 with the 5 because I know that they should not have a GCF. 2 and 15, well, I would not put the 15 with the 5. So let's put the 2 here and the 15 here. That gives us 2x and 75. Those are way too far apart and would never give me 13. So let's try 1 and 30. Oop, I would not put the 30 with the 5. I'd put the 30 over here and the 1 over here, and that would give me 1x and 150. Oh my goodness, that's not going to give me 13. What does that mean? Oh my goodness, that means I made a silly mistake. If you look here, I put an x, not a 2x. That's not going to get us the 10x squared we need. So I'm going to have to try this all over again just because I made a silly mistake, but that's okay. It happens. Luckily, I caught that. So I'm going to put a 2x here instead. It's not going to be 5x and x. It's going to be 5x and 2x. So let's try our pairs again. 1 and 30, 2 and 15, 3 and 10, 5 and 6. Again, I would not put the 5 here. I'd put the 5 with the 2 and the 6 here. That gives me 12. That gives me 25. Well, 12x and 25x. Well, 12x and 25x ever subtract to 13? Actually, it would if their signs were different, which they are, but the bigger needs to be positive. So the bigger would have to be 25x, so that would get a plus. This would get a minus. That would result in a negative 12x and a positive 25x. And when you add those two numbers together, well, when you add two numbers whose signs are different, you subtract and keep the sign of the larger. So 25 minus 12 gives me a positive 13x, and that is what I need. I cannot believe that our first try would have been correct if I had that 2 there earlier. Let's just analyze our factors to see if we could keep going. 2 always drops. 5x minus 6 is a difference. It is a difference of 2 terms, but neither one is a perfect square, so it is done. 2x plus 5 is a binomial, but it's addition, so we will never use difference of 2 squares on it. So after you factor, and if you have a binomial, the only time you could keep going with a binomial is if it's dots. So if it's not a difference like this one was, you know it's not going to keep going, which means these 3 are our prime factors. I have a flow chart down here just to kind of sum up what some possible combinations are. There are other combinations, but these are the most common. First thing you always try is GCF. If it's a binomial, you attempt dots. Attempt. Has to be a difference of 2 squares. If it's a trinomial, you're going to attempt to factor with, your 2 sets of parentheses. Pay attention to whether a is equal to 1 or a is greater than 1. Check your outers and your inners. Make sure you're using the correct signs. Another possible combination is dots and then dots again. I'm actually going to perhaps try one of those for a second, just so that you see it. I regret not putting it in the lessons, so I'm going to show you what I mean by that. An example of dots with dots would be like x to the 4th minus 16. Okay, well, this is a difference of 2 perfect squares. So I'll make 2 sets of parentheses. So this line from here to here, I'm using dots. I would get x squared with an x squared, a 4 with a 4. I would get a plus and a minus because signs need to be different. Now, if you look, x squared plus 4 is a binomial, but it is not a difference, which means it is done. Notice I'm analyzing. I'm not just writing. Listen to my thought process as I do this. Now let's look at x squared minus 4. It is a difference. It is a binomial, aka the 2. And they are both perfect squares. So this is not done. This does break down again into x and x, 2 and 2. Signs need to be different, so we get a plus and then a minus. We already knew x squared plus 4 was done. X plus 2 is absolutely done because it's a plus. Let's just further analyze x minus 2. Is it a difference? Yes, it is. Is it a binomial? Yes, it is. Are they both perfect squares? No, they're not. So this is done. Again, how do I know that? I don't really know that. I analyze it to determine it, which means this is my final answer. If you noticed, we did do dots twice. We tried dots a 3rd time, but we could not do it. So that's your example of dots and then dots again. All right, so you're going to do the delta math, and then you're going to attempt a quizzes. And that is all for factoring.